Hello friends, welcome back to our channel. So today we'll see one more problem in algorithms concept, that is multi-stage graphs problem. Multi-stage graphs. So here the name itself indicates the multi-stage graph, means here this is a graph problem. It is a graph problem. And what is this problem? And here we need to find the shortest path from source to destination. So already we have solved the similar problem by using a different methodology, by using the greedy methods. But here we are supposed to solve this one by using the dynamic programming, right? So finding shortest path from source to destination. So here we are having a few constraints. In order to find the shortest path, we are supposed to have some constraints. So that is, we need to use the weighted and directed graph. So only we have to take the weighted and directed graph. And here the vertices will be divided into different stages. Okay, so some sort of partitions, right? So vertices were divided into partitions called stages. So each stage will be having a subset of vertices, and so the direction should be only one word, right? So if the direction is from current vertex to the next vertex, so there should not be an edge between next vertex to the current vertex. So I'll show you the example so that you can understand. So if the graph is like this, so if A, B, and let us take this C, D, okay. So these are our different vertices, okay. If there is an edges like this, okay, so this is one partition, this is another partition. So here we can say K1 is a stage, K2 is another stage, and K3 is another stage. So in this stage K1 we are having one vertex, in K2 we are having two vertices, in K3 we are having one vertex, and there should not be direction in this way. So in this example you can see the direction is towards the destination, right? A to B or A to C, and B to D or C to D. And the direction should not be like this. So one is towards destination and another one is towards the source. So this type of graph is not applicable, right? So the direction should be towards the destination only. For example, let us take this as a source, right? And this as a destination. Then the direction should be towards the only destination, not towards the source. And also every edge should have a weight. For example, the weight is 5, 2, 3 and 6. So you can call them as a weight or a cost or a distance, anything, right? Weight, cost or a distance. So there should be this one. So such type of graph we can call it as a weighted directed graph. So here we are having the directions and also weight for each and every edge. So this will be the weighted and directed graph. So in order to solve this graph problem, multi-stage graph problem, so the graph should be weighted and directed, and the partitions, the complete vertex should be in partitions called as stages, and the direction should always to be towards the destination. right? Then we can solve this by using the dynamic programming, and such type of problems can be solved by using two approaches. One is forward approach, another one is backward approach. So if you are using this forward approach, we are supposed to select the destination first and we need to solve the problem. So that we call it as a forward approach. Don't get confused. In the forward approach, we are supposed to start our process from the destination itself. And if it is a backward, we have to start from the source itself. Okay. Now in this session, we will see the forward approach of solving this multi-stage graph problem. So let us take an example and we'll solve this multi-stage graph problem using dynamic programming using this forward approach. So come up with an example. See, let us solve this example. So this is a weighted and directed graph. You can see the directions, and also for every edge we are having some weight or cost or distance, right? And also all the directions are towards the destination. For example, consider this as a source and this one as a destination. Alright. Now we need to find the shortest path from source to destination, right? So based upon the edges. So we can start from source and we can reach the destination in different paths. We can go with A to B, B to F, F to H, or A to B, B to E, E to H. See, A to B, B to E, and E to H. A to C, C to F, F to H. A to D, D to G, G to H. Similarly, A to C, C to E, E to H. So like this, we will be having a lot of solutions, lot of possible paths, right? But we are supposed to select the path with an optimized route. That means the weight, the cost should be a minimum. That means that we call it as a shortest path. So such type of problems we can say them as a optimization problems. So where the problem is having a lot of solutions and we have to select a solution based upon the constraint. So here also the constraint is shortest distance, shortest path, right? Now let us check here how many stages we are having. Let us assume this is a stage 1 and this is stage 2. This is a stage 3 and this one is a stage 4. Alright, let us assume K as a stages. So there are 4 stages. So K1 is having only one vertex, K2 is having a 3 vertices, K3 is having a 3 vertices, and K4 is having only one vertex. So we need to start from the destination if we are going with the forward approach. So let us go with the K4, right? So we can call it as a cost of K4 comma, what is a vertex H. We need to find out the cost for K4 to H. So where the formula will be the distance of H to H. So which we can call it as a cost. Okay, cost of H and H. So the destination and source of both are equal, then obviously the weight is 0, right? If the source and destination both are equal, then we can say the weight is 0. So it will be 0. Now, any other vertex available in K4? No. Now we can move with the K3. So K3, the cost of K3 comma, let us find out for E. Okay, then what is this one? So cost of E to destination, right? So E to destination, what is the cost of E to destination here? The distance from E comma H plus cost of h comma h. So here we are having the destination, so E to H and H to H. For example, if it is B, we need to find out the B to E plus the cost of E and H. Okay, hope you understood. So we need to find out the distance from B to H. Then obviously we can say the distance of B to E and from E to H. So similarly, if we are finding the cost E comma H, then the distance of E to H and the cost of H and H. If we are having a multiple paths, we need to find out the minimum. So what is the value here? So DE comma H, 18 plus, we need not find out the value once again because already we have calculated here. So that is an advantage of dynamic programming. So we are supposed to solve the problems and save the solution in order to avoid the calculation. Once again calculating the same problem. So here cost of H is 0, which is 18. So is there any vertex in K3? Yes, F is there. So once again cost of K3 comma F. So which means cost of F to destination is equal to the distance from F to H plus a cost of H to H. So what is the distance of F to H? 13 plus cost of H to H. It's 0, which is 13. Next, again we need to find out the cost of K3 comma, there is one more vertex G. So cost of G to H, which we can say the distance of G comma H plus cost of H to H. So what is the value of this one? D distance of G to H. G to H, it is 2 plus 0, which is equal to 2. So we have completed the K3. Now we need to move with K2. So K2 edges are DCB. Now let us find out the cost of K2 comma B. Right? Now we need to find out the cost of B to H. So we need to find out the B to H, the cost of B to H. Now you can see, now you can understand why we are writing here this one. So B to H means, so there are different possibilities. So B to E, E to H, B to F, F to H, right? B to E, E to H, B to F, F to H. So there are multiple possibilities. Here we need to find out the minimum. So minimum of distance of BE, distance of B comma E plus, now we are at E, so we need to find out the cost of E comma H. So cost of E comma H, which was already found here, see, right? Similarly, I'll write here D of C comma E, sorry, B comma F, because from B we can reach H through E or through F, okay, two paths. So we need to find out the minimum plus the cost of F comma H. That is also we have found F comma H, right? Now calculate DBE. DBE means 4 plus cost of EH, we have find out 18. So which gives it 22. And next possibility BF, B to F, it is 11 plus cost of F comma H, which is at 13. So which is 24. So we need to consider the lowest, so the minimum. Next, there is a one more edge, one more vertex in K2. Now we need to find the cost of K2 comma C. That means cost of C to H. What is the cost from edge vertex C to vertex H? So that we can also have a minimum because we are having multiple paths, C to E, C to F, C to G. 3 possible paths are there, right? So minimum of D of C to E plus cost of E to H. Similarly, D of C to F plus cost of F to H. Similarly, D of C to G plus cost of G to H. See, there are 3 outgoing edges. So we can reach H from C via E or F or G. So 3 possibilities. So we need to find out the distance of C to E and cost of E and H. Distance of D to C and F and cost of F and H. Distance of C and G and cost of G and H. So what's the value here? What's the value? D of CE. CE is 9 plus E and H. So what's the E and H? Cost of E and H already we have find out, right? So here 18. We have calculated, so 18, which is 27. And here C and F, it's a 5 plus cost of FH, already calculated, cost of FH, which is 13. Next, D of CG, CG it's 16 plus cost of GH, cost of GH, it's 2. So how much? This is 27, 9 plus 18, which is 27, 5 plus 13, which is 18, 16 plus 2, which is again 18. So we can consider 2 possibilities. One is reaching H through F or reaching H through G. Both are equal cost. Right. Leave it. Now, is there any vertex in K2, stage 2? Yes, there is a edge, there is a vertex of D. So again, find out the cost of K2 comma D, which is nothing but cost of D to H. So here, whether it is required to find the minimum value. Whether it is required to find the minimum value? No, because only one path is there from D to H. There is no outgoing edge, only one edge is there. So we can write it as D of D to G plus cost of G to H, which gives D to G, it is 2 plus cost of G to H, again it's 2. So 2 plus 2, which is a 4, which is 4, right? So is there any vertex in stage 2? B, C, D. We have calculated B, C, D. All possibilities. So there is no vertex in stage 2. Now go with the stage 1, which is a source. Then K1, the cost of K1 comma A, which is cost of A to H. A to H. How many edges are there? 3 edges are there. So we have to find out the minimum among these 3. So minimum of distance of A to B plus cost of B to H. So we did not find again B to E and E to H. Already we have calculated everything. So A to B and cost of B to H. And see again D of A to C plus cost of C to H. Again D of A to D plus cost of D to H. So among these things we have to find out the minimum. Now find out D of A comma B. What is the distance of AB? 1 plus cost of BH. Already we have calculated somewhere. BH, cost of BH. See, cost of BH, this one. So among these two we have considered minimum. So 22, we need to consider the 22, which is the 23 cost. Now D of AC is 2 plus cost of CH. So here we have calculated cost of CH. So 18, we can consider anything, right? Either, because both are equal. So I am considering 18, which is 20. Next, D of AD, A to D, it is 5 plus cost of DH. What's a DH? Once again here, B to H, C to H, and D to H is 4. So it is 4, which is a 9, right? So among these three, what is the minimum? This is the minimum. This is the minimum. So we can consider 9, and this is the first stage. So that means a source. So in order to find the path from source to destination, the minimum path is a 9, right? So we have to find out the path. So 9 means A to D. Okay. So first A to D, then cost of DH. Go to the cost of DH. Where is the DH? This one. So here DH, it is G, D to G. So after D we have to visit a G, and then cost of GH. What's the GH here? GH. So from G we can go with the H. From G we can go with the H. So among all the different paths, this one is the shortest path. You can observe A to D, D to G, G to H, which is 5 plus 2 plus 2, which is 9. So if you go with A to C, C to F, F and F to H, 2 plus 5, 7, 7 plus 13, 20 it will take. And if you go with A to B, B to E, E to H, 1 plus 4, 5 plus 18, 23 it will take, right? So this is the only path which is having the shortest distance. So in order to reach from source to destination, the shortest path is A to D, D to G, and G to H, right? So here what we have to do is we have to start with the destination, and from the destination try to find out the cost from each and every stage towards the destination. So here the cost of fourth stage, which is a destination to destination, the cost will be 0. So only one node is there, right? So once again, one more constraint is here in this problem, the graph should contain only one source and one destination. And coming to the third stage, from the third stage we are having the 3 nodes, and from the 3 nodes we have to find out the cost from each node to the destination, so E to H. If there are multiple paths, we need to find out the minimum. We need to consider the minimum. So how we can use? We have to find out the distance from E to H and a cost from H to H. So here you can find out, here you can understand, if you are finding the distance cost of B to H, what we are doing, we are finding the distance of B to E plus the cost from E to H. So obviously we have calculated the cost of E and H, the same value we are using here. So in the dynamic programming, the complete problem will be solved into, divided into sub-problems. Those are the overlapping sub-problems, and each sub-problem will be solved and the solution will be stored in the memory, so that in further we can make use of that particular solution in order to get the final solution, optimal solution. So the same thing happens here. For every situation we are saving the solution. So the same solution we are using in our next recursions, right? So hope you understood this multi-stage graph problem. Okay, so let's stop here. Hope you enjoyed the session. I'll explain you in the next session with one more complex example, right, with the different stages, by increasing different stages, so that you will be understanding how we can solve it, right? So let's stop here. If you are having any doubts regarding this problem, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. So thanks for watching. Thank you very much.